Good morning, students. This is Ravi sir taking maths from Devashin International Public School, and we were doing the chapter Introduction to Euclid's Geometry. So today we are starting with the exercise 5.1. Now in this exercise, students, we are going to answer some of the questions and we are going to prove some of the results, okay, using Euclid's definitions, postulates and axioms. Okay, so the first question says, which of the following statements are true and which are false? So that means there will be some of the statements, students, and we need to analyze the statement and we need to answer it whether the statements are true or whether they are false. And apart from that, we need to give reason also for our answers. Okay, so the first statement, student, is only one line can pass through a single point. So if there is a single point, let's assume O, then there is only one line which can pass through that single point. Okay, so is this statement right or wrong, true or false? So student, this statement is actually false. Okay, why? Because if we mark a point O on the surface of a paper and using pencil and a ruler, we can actually draw an indefinite number of straight lines passing through a point O. Okay, so see student, the statement was only one line can pass through a single point. So this answer is actually wrong. This is false, because if we mark a point O, let's just mark a point O. If we mark a point O on the surface of a paper and then using pencil and ruler, we can draw an indefinite number of straight lines. Indefinite number of straight lines, that means infinite number of, that means many number of straight lines passing through point O. Okay, so if this is the point O, then I can draw as many number of lines passing through point O. There can be infinite number of lines passing through point O. Okay, so this statement is actually false. Okay. Second statement we have, student, there are an infinite number of lines which pass through two distinct points. That means if we have two distinct separate points, then the statement says there are indefinite number of lines which can pass through these two separate points. Let's check it. Now imagine, student, this is one point, let's say P, and there is one point, let's say P, and there is another point which is Q. Now there are some lines passing through these two points. Okay, there are many lines passing through point P and there are many lines passing through point Q. Okay. Now what does the statement say? Statement says that if there are two separate points, two distinct points means two separate points. Now we have two separate points. One is point P, this one, and another is point Q. Okay. So in that case, it says there are an infinite number of lines. Infinite, that means many number of lines which can pass through these 2 points, both the points together. Now see students, if we check this point P, there are many straight lines passing through this point P. If we check point Q, then again there are many straight lines which are passing through point Q. But students, there is one and only one line which is passing through point P as well as Q. Okay, there is only one single line which is passing through both the points. Okay, so in this case, how do we write the answer? Now this statement is actually wrong. This statement is false. So we say false. So we need to give the reason also. Okay, so because in the following figure, in the following figure, there are many straight lines passing through point P, and there are many straight lines passing through point Q, but there is one and only one straight line passing through point P and as well as point P as well as point Q. Okay, so let's again revise it. The statement says there are an infinite number of lines which passes through two distinct points. So if we have two distinct points means two separate points P and Q. These are two separate points. Then the statement says that there are infinite number of lines, straight lines, which can pass through these 2 points. Now if we see the figure, students, there is only one line which is passing through point P and also through Q. Okay, but if we separately check the point P, there are so many lines passing through point P and there are so many lines passing through point Q, but there is only one line which is passing through both the points together. Okay, the answer you have to write in this way. The statement is false because in the following figure there are many straight lines passing through point P and there are many straight lines passing through point Q, but there is only one straight line passing through point P as well as point Q. Okay, students? Okay, Roman number 3, the statement, it says a terminated line can be produced indefinitely on both the sides. Now remember, student, we had actually studied the postulate number 2 of Euclid, right? So in that case we studied that what today we call as a line segment is what Euclid called it as a terminated line, right? What Euclid called as a terminated line, today we understand it as a line segment. So let's draw a line segment. let's take a line segment A and B. Okay, so this is the line segment AB, which Euclid called it as a terminated line. So it says a terminated line can be produced infinitely on both the side. Okay, so we already know that, student, this is the line segment AB. This can be produced on both the side infinitely, or it can be produced on both the side indefinitely. Okay, so in this case, student, this statement is actually true, and we need to give the reason. Because according to Euclid's postulate number 2, which says that a terminated line can be produced on both the sides infinitely. Okay, so let's once again revise it. The statement says the terminated line can be produced indefinitely on both the sides. So what does a terminated line mean? A terminated line means a line segment. So we have taken example, this is the line segment AB, and it says it can be produced indefinitely on both the sides. So of course, students, it's but obvious that we can produce this line segment on both the sides infinitely. So the statement is true because according to the Euclid's postulate number 2, which says that a terminated line can be produced on both the sides infinitely. Roman number 4, the statement says that if two circles are equal, then their radii are equal. If two circles are equal, okay, so let's first of all draw two circles. Now, imagine we have two circles. One is A, and the center is A, and the other circle which has the center B. Okay. Now, student, these are two circles. The circle with center A and the circle with center B. Okay. So the statement says if two circles are equal. The statement says that these two circles are equals. When can two circles be equal, students? Now, if we try to superimpose the region of one circle on the other circle, if we try to superimpose the region of one circle on the other circle, then we find them coinciding. Okay, so in that case, what will happen, students? Their centers as well as their boundaries will coincide. Okay, so in that case we can say that their radii also coincides. Okay, so how do we write these statements? That means this statement is actually true. Okay, so we need to give the reason. Because superimposing the region of one circle on the other, we find them coinciding. We find them coinciding. So their centers and boundaries coincides. Okay, thus we can say their radii will also coincide. So the statement is true. Let's just understand once again. The statement says if two circles are equal, then their radii are equal. So we have drawn the two circles. The statement itself says that the two circles are already equal. When can we say that two circles are already equal? When we try to superimpose the region of one circle on the other circle, then in that case they coincide on each other. Also their boundaries as well as their center also coincides. So in that case we can say that their radii coincides. So the radii are equal. Okay, so the statement is true because superimposing the region of one circle on the other, we find them coinciding. So their centers as well as their boundaries coincides, thus their radii will also coincide. Okay student, now we will do Roman number 5 in question number 1. The statement says that in the given figure, if line segment AB is equal to line segment PQ and line segment PQ is equal to line segment XY, then line segment AB will be equal to line segment XY. Okay, so the statement says if line segment AB is equal to line segment PQ and line segment PQ is again equal to line segment XY, then line segment AB will be equal to line segment XY. Okay, so this is something like, if A is equal to B and B is equal to C, then A is equal to C. Okay, so in the solution, the statement is actually true. Okay, we need to give the reason. So what is the reason? According to Euclid's axiom, which says that if things which are equal to the same thing, then they are equal to one another. Okay, so the statement is true. According to the Euclid's axiom, it says if things which are equal to the same thing, then they are equal to one another. Okay, so students, we have completed the question number 1 of exercise 5.1. We will continue with the rest of the sums in our next upcoming videos. Till then, keep practicing. In this way, you will improve a lot. Okay, take care.